And you could write down rules for ray diagrams for convex or diverging mirrors. There's rule number 1. I'm going to draw them up with you. So I'm going to make the switch to the input. There's no other signal. That's a big lie. Oh, no, there is. It's not a lie. I got to plug this in. So get that out of the way. Plug this in. All right, we're going to do one more technical move. Going to switch the input. Oh, excellent. Good. I'm hoping there's right there. Beautiful. And I am going to, just like we did the other day, I'm going to draw a principal axis. Actually, I'll draw it this way. No, I'll draw it this way. I'm going to draw a principal axis. Right, and again, the reason I'm recording it this way is because I want you to see the way I'm doing this. Just checking to make sure I can see it on the other camera. This time, I'm going to draw it over here, right? Because it's diverging. So I'm drawing it on this side. Okay, everybody catching that? And this time, it's going to be 5 centimeters on the back side, and that's inches. 5 centimeters. Where is 5 centimeters? Right there, 5 centimeters. And 2.5 FC, back of the mirror is over here. All right? And that is diverging. Diverging or convex. And rule number 1, I believe it said array parallel to the principal axis. Is that correct? Array parallel to the principal axis. 1, A, ray parallel to PA will. All right. Which way is it going to go? It's going to reflect, but it's going to reflect a certain way. Yep. Oh.
On the page, it's like the other way, so we just draw it the other way.
The other way.
So like,
Oh, no, draw it like my way. Don't worry about it, you'll be fine. Draw it like I have it right here. You'll be fine, your brain will be able to flip it over. I want you to draw it like mine.
okay, yeah.
Yep. You're saying that on my picture it looks like this. Well, that's not a problem. Yeah, you just have it come from the other side. Yep. There's no handedness to light, right? But I'm just drawing it this way, just because. We like our picture? It's looking good. So, where is this ray going to bend? Well, take a look at the mirror. Just in general, which way is it going to head? Not necessarily to a spot or anything, but in general. Shane, what do you think? Up and away, right? It is. It's going to bend up and away because it's going to hit that normal there and it's going to take off that way. It's going to do it in a specific manner. It's going to bend up and away. How? Megan? You got any ideas? McClintock, what do you got?
The reflected ray.
Right, very good. If you extend the reflected ray, so the way I like to describe it is, it reflects as if it came from F. So it reflects away, up and away, as if it came from F. And I'm going to extend that in behind because you know what? For a diverging mirror, we always have to extend it behind. So there's rule number 1. A ray parallel to the principal axis will reflect away as if to come from F. Okay? Number 2, we're going to do them all in one shot. Second one is a ray that appears to go through F. So in the second rule, we had a ray that was aimed right at F. So number 2, a ray that appears to go through F will, all right, a ray that appears to go through F will. So I'm going to just take a ray here that appears to go through F. Again, this isn't a ray diagram. This is the rules. For a ray diagram, the rays always have to come from the top of the arrow, right? This is just 3 practice rays. So a ray that appears to go through F, how is it going to come out? Any ideas? Yep. Parallel to the PA. Now, it's the rays that come out that we extend in behind. All right, and look at that is the most horrific parallel attempt at parallelness ever. You see that? That's terrible. That's not even close to parallel. But I'm going to leave it. I don't want to erase that. Rule number 2. How many rays do I need in order to find something interesting on my pictures? 2. And I've got 3 rules. Rule number 2, we actually never ever really need to use rule number 2. Rule number 2 is a real pain because students always extend the wrong one in behind. They want to extend the first one in, but it's actually the one that comes out that we extend in behind, and students always make mistakes on it. I don't ever use rule number 2 because it's really a pain. It's a trick to use. Anyway, let's write it down anyway. A ray that appears to go through F will emerge parallel to the PA. Awesome. Last rule. What's the important? Yep.
What do you mean?
It's not hard to do. It's that when we go to look for the cross point, students extend the wrong ray behind the mirror. They often extend the ray that's going into the mirror heading to F, as opposed to extending the ray that comes out from the mirror, which is parallel. So they extend the wrong ray and they find the wrong location. So it's error prone. It's prone for people making mistakes because they always want to do it like the first one, right? And so I say forget about 2 because then you won't make the mistake. Third rule. What point am I interested in the third rule? Where am I heading to? C, a ray that is heading towards C. Again, I'm not doing a ray diagram. I'm just doing example rays. A ray that heads to C, what does it do? It's just like the other one. Yep, Emily. Comes back on itself, and I'm going to extend the ray that comes out behind the mirror, and because it's coming back on itself, it's really easy. I just extend that one all the way through because it's going to come back on itself. So I like rules 1 and 3. And because the focus is in behind the mirror, you can never put an object on the focus because the focus is a virtual focus. It's in the mirror. The focus is in the mirror itself. It's in the virtual world. We can't really put anything there. Kind of trippy, but hopefully it makes sense. Yes. Zoop. Ray number 3. A ray that appears to go through C will reflect back on itself. All right? Okay? Yep. Yeah, we will be doing a SALT as well. So in a moment, I'm going to do one ray diagram with you, and then many of you printed off the sheet, and that's great, but you know what? In later on years, the last time I taught this, I didn't even print that sheet because it doesn't matter where the object is. You get the same SALT every time. You are actually drawing the same ray diagram over and over and over again, so it's really not that exciting. So let's draw one, and then if you've got the sheet printed, that's awesome. But if you don't have the sheet printed, don't worry about it. One example's enough. That's good. Did you think you were in Mr. Petrus's class? That's awesome. Okay, so let's do one example. Example. Yep, that's great. Just leave it right there. That's good. Okay, so I'm going to draw the principal axis. And using my protractor, I'm going to draw the mirror, just like we've been doing. And I am going to put it right there. That looks good. Notice how I'm not letting the mirror kind of fall off the edge of my principal axis, because that's where my F and my C are going to be. There's C, and 2.5 is F. And again, the blocks work great. Yep. Yep. No, I'm not really that concerned about it. No. I do like to see the little marks on the back, so I know whether it's concave or convex. And then I like to see the rays going in, the rays coming out, because then I can quickly see whether you extended the right ones in behind, right? Because you will be getting an assignment, I don't know if we'll get to it today, where I'm going to have you do some calculations and draw ray diagrams, and I'm going to mark you up on the ray diagram, okay? All right, so let's put an object out in front. And you know what? It makes no difference where you put it in front. For a convex mirror, all the ray diagrams are the same. So I'm just going to go out here somewhere, and I'm going to use 3 blocks here, which looks like about, what is that? That's about 2 centimeters worth. And again, it doesn't matter where you put it. It doesn't matter how big, as long as it's not like bigger than the mirror itself. And that is my object. And now let's find the image. So I like rule number 1, a ray that's parallel to the principal axis. They're coming in. And you can make the sound effects that I like to make when I draw rays. I don't know if you've been hearing me, but I make little noises when I draw my rays. Anyway, it's going to reflect away as if it came from F. And I'm going to tell you right now, we always have to extend in behind, so don't move the ruler, just automatically extend behind. Ray 2, let's not bother with it, because we're not going to need it. Ray 3, coming from the top of the object and putting the other ruler end where the C is, all right? A ray that appears to go through C will reflect back on itself, and therefore we're going to extend it, because we always extend. In, out. And the reflected rays are diverging, so we extend them in behind, and right there, our little dotted rays meet. And right there, we have our image. Again, with the base always on the principal axis. So, salt. Size. Yep, Emily? Smaller. Attitude. Yeah, Megan? Upright. Upright. Location. Try to be a little specific. See, be as specific as you can. We don't need distances here. Yep. In front of F. Yep, that's good. I would take that. I like between F and the mirror. It's a little, it's, you know what I mean, it puts it in there. But if you said in front of F, that would qualify. Between F and mirror. And what type is this? Yep. Yeah, it's in behind the mirror. That's the virtual world. It is virtual. Now, on my next slide, you can't see the slide right now, but on my next slide is a summary. And the summary, this is the summary. It doesn't matter where we put this thing. If we put it here, or we put it way out here, the salt is still going to be the same. This is the summary, all right? That is the case for all diverging mirrors. It will always have the same image characteristics. So diverging mirrors just aren't very exciting at all right? They don't have anything exciting in terms of that, okay? So if you've got the sheet and you want to complete it for all those different spots, you're going to be doing the same thing over and over again. If you don't have the sheet, you don't want to print it, don't worry about it. It's just like this, okay? Maybe for a quiz or for and we are having a quiz next Thursday, or a test, You're gonna wanna maybe practice one. Ha, that's funny. Yeah, no problem. Yeah, they're so funny up there. All right, so I'm gonna stop this for a minute because that's done, and I'm actually gonna stop the recording on this side. You guys can't see it right now, but I'm gonna stop that right